So this is lesson 147, page 265 and 266. So we are doing two-step equations today. So it's similar to what we were doing, of course, with the regular equations. I told you we're going to get more complex, so we were working on the steps. Here's where we're really going to start putting it into place. And again, these are still simple compared to the larger ones that you're going to get even in 7th grade. First, for a quick review, I've been noticing a lot of mistakes when it comes to, I'm going to move this over, finding the area and the circumference of a circle. Remember, circumference formula is pi times diameter. When they give us a radius, some of you are just still plugging this in here, but that's not what this formula is. Okay? Area is pi times the radius squared. So I've drawn a reminder here. Several of you are familiar with this, but please be patient and wait because there are about half the class that are making this common error. The diameter is the distance all the way across, from one side of the circle to the next. The radius is half of that. So if they give us a radius, let's say of 2 feet, and they ask us to find the circumference, which is the distance around, we don't do pi times 2. Because you have to pay attention that they gave the radius and not the diameter. So if the radius is 2 feet, you should be able by now to remember that the diameter is double that, 4 feet. So pi times 4 to get the circumference. If they give you a diameter and they ask for the area, you need to remember that we have to cut it in half. So let's say they tell us that the diameter is 12 inches. We don't want to use 12 in this formula. We have to remember that the radius is half of that diameter. So if the diameter is 12 inches, our radius is 6 inches. That's what we would use. 6 squared, 36, times pi. And of course, it's in square feet, square inches, whatever unit they give us, it's always going to be squared. A lot of you are forgetting this part as well. Write these two formulas down if you need to. I've seen way too many frequent errors on this, and I want to make sure that we catch it, even though I'm not there directing you or telling you the answers every day like I usually would if we're in the classroom. So circumference, the distance around, pi times diameter, that's the whole length across, that's double the radius. Area, that's everything that fills in the circle, is pi times the radius squared. That is only halfway across from the center to the outside. It is half the diameter. So make sure you are working carefully when we have these types of problems. Are they asking us for circumference? We need to know the diameter. Are they asking us for area? We need to know the radius. And we can find the diameter or the radius. If they only give us one, that should be easy. Diameter, double the radius. Radius, half of the diameter. All right, let's jump into the review part with the first 3 problems. And then we will get to the actual topic today, which is two-step equations. All right, so starting with these, we're going to be changing these to decimals because here's another area where I've seen frequent errors. We're used to this, so most of you do remember that 1/4 is 25%. That has not been an issue. Here's where we're starting to make mistakes. I see all kinds of different answers. When it's 724%, remember that decimal point only moves 2 places. When we are converting it to a decimal, the percent sign is gone. So if I were to take this and change it to a decimal, again, I would move it that 2 places. You guys are familiar with these. I haven't seen errors in these short or simple ones, but when we're getting into ones like this that are greater than 100%, I'm seeing a lot of mistakes, as well as these. Please, I've gone over this already in some of my past video lessons, but this is important because you're still forgetting how we change it to a decimal. Yes, you guys are recognizing that 8 1/5 is 8.2. That's fine, except it's 8.2%. We haven't converted anything to a decimal number. We have a decimal point in the percent, but this is not in its decimal form. So if we were going to find 8 1/5% of something, most of you are going in and multiplying it by 8.2. That is a big problem because that is not 8 1/5%. You are finding 820% of something if you do it that way, if you're doing it the wrong way. These two are the same. We've just written it in a different form. Now we have to convert it to a true decimal number by moving that decimal point over. .082 is what we would multiply by if we were finding 8 1/5% of something. So you're getting that 1/5 is 0.2, but you're forgetting that this is still the percent form. It's just got a decimal point in it. The true decimal form is where we get rid of the percent sign by moving it over 2 places and giving us .082. And I've seen a lot of mistakes on this on the work you've been sending me in, which is why I wanted you to send in pictures, because it's helpful for me to see where we're still making errors so that I can come back and review those things over again. All right, today's lesson on two-step equations. We've already talked about with equations, we have a goal. What is it? Get the variable alone. Our first step is always to simplify the side of the equal sign without the variable. Well, what happens if that side is simplified, but the other side is not? We're still going to go through it step by step as one process. We're still going to do the same to both sides because that equal sign has to keep everything balanced, but we're just interjecting a new step in between where we undo the problem, okay? So we don't have anything on the side with the 13 or the 2 or the 16. That's already simplified. What we do have are 2 operations on the side with the variable. That's why it's called a two-step equation. There's 2 parts we're going to do. When you have 2 operations with the variable, it's important to always do the subtraction or addition and get rid of that first. Okay, think of it as these are attached. Okay, so those are the last things that we're going to separate or take care of. All right, this is like the baby of the family, and they're attached to the mama's skirts for longer than the older kids. The older kids, they have to leave first. So we take care of the addition and subtraction, right? The old kids that we want out of the house first, and we undo those. So instead of +5, I'm going to get rid of that by taking it away. I'm subtracting it so that it's gone. But if you remember, I've got to keep it equal, right? So I have to subtract 5 on this side. I still have 2x. Here's where all those steps of rewriting is important because we want to show what we're still working with and what we haven't taken care of. I have not taken care of the 2x. The baby's still with the mama. 13 minus 5, I can simplify to 8. And now we're down to the very simple form of equation that we were working with last time. Okay? Now we can undo the operation that's stuck with the variable. Now the baby's grown up, and it's time for the baby to move out of the house as well. How do we undo this operation? Did you remember this means multiply? Then we undo it by doing the opposite, which is dividing. Okay, I'm dividing by that 2. Remember, we're starting to use that fraction bar as our division sign. We're not doing this little baby stuff anymore, right? Baby's grown up. So this is gone. But to keep it equal, I also have to divide by 2 here. Okay, so the same operation on both sides keeps it balanced. X, that's all I got left with, which was my goal, get the variable alone. Okay, and then we can divide 8 divided by 2. There are a few of you who have been so super helpful by circling this part of your work Some of you are circling the fact that you checked it. It's great, but this helps me so much when I'm trying to grade pictures that you've emailed or texted me so I can see your actual value. But yes, I really appreciate that you're all going back and showing checking, which is important. So we're going to do the same thing. Now we have learned that we don't use the x for multiplying anymore. So even though this is multiplying, you can either use your dot, or it's a good idea to get in the habit of remembering anything next to parentheses is multiplying. So that's how I'm going to put it in there. I would like you to use that way because that's going to give you a good foot forward for next year. So we're rewriting the original equation, substituting in our value. X is 4. So 2 times x becomes 2 times 4 plus 5 equals 13. Now remember, order of operations matters. PEMDAS, parentheses, nothing to do inside. Exponents, none. Multiplying and dividing, there's my 8 plus 5 equals 13. Now I can do my addition and subtraction last. 13 does equal 13. So we checked it, and we know that this is the correct solution. So when you're circling this doesn't really show me what value you had. Circling this shows me the answer that you found, and then all of this is just proof that you know that you've gone back and checked and saw that you had it right, okay? So thank you, those of you that are already ahead and on top of this. It was awesome. The rest of you, if you could start doing this, that would help me out immensely. Doesn't count off for it, but it really helps. Here, same goal. Get the variable alone. There's nothing to do on this side, but we have two things. Again, the older kid's gonna go first. They're not quite attached to the mama anymore. How do I undo minus 6? If I've taken something away, I fix it by putting it back. Plus 6, but I have to keep it equal, and it is important that you show your work. That I do take points off because you guys know my expectations and you need to show these steps. Just putting an answer, x equals 4, not good enough. Showing the work, beautiful. So we still have an x over 3. Baby's still with the mama, haven't dealt with that yet. It's coming though. Equals, and then 2 plus 6 is 8. Now we've simplified something so that we only have one more step to go. How do we get rid of this 3? If you remember, this is a division bar, right? Baby's growing up, this is dividing. Well, to undo that, we do the opposite, which is multiplying. You could use the dot, but parentheses is what you're going to see more often. May as well get used to it now. Now I have x by itself. Oh, sorry, these two are equal. Multiply by 3, multiply by 3. 8 times 3, 24. Here's my value for x. So let's plug it back into the original equation. 24 over 3 minus 6 equals 2. And let's check it. 24 divided by 3 is 8. So I still have 8 minus 6 equals 2. That is 2, which equals 2. Check. We've done it correctly. Here, we don't care if there's exponents in it. We know how to follow the steps. We can simplify that, no problem, if we do one thing at a time. We're not going to move the baby out first. He's still attached to his mama. Okay? Nothing wrong with that for now. This, we've got to simplify something before we can take care of this, right? We need to put this in simpler terms so we can add or subtract the correct thing. 2 squared means 2 multiplied twice, right? Don't forget. So really, this is a 6x plus 4 equals 16. So This one is almost like doing a three-step equation already in 6th grade. You guys are pros. Now we know exactly what the older kid is. We've got to take it away, but we've got to keep it equal. Minus 4 over here. 6x, baby still with the mama, equals, now 16 minus 4. Well, how do I get rid of the 6 so that the x is alone? Because that's our goal, right? Every parent wants their kids out of the house. They don't want anyone stuck in the basement playing video games for the rest of their lives, even until they're 35. All right, we've got to get rid of the baby. It's time to grow up. How do we do it? Remember, this is multiplying. So to undo multiplying, we're going to divide using that fraction bar. We're going to keep it equal. Now x is alone. This is the parent partying because they've got an empty house, no more children in it. Hopefully there'll be grandkids coming much, 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 much later. 12 divided by 6. And we have the value for x is 2. So let's test it by, again, plugging it back in. 6 times x, well, x is 2, so it's going to be 6 times 2. Parentheses means multiply. Plus 2 squared equals 16. There's nothing in parentheses, but there are exponents. PEMDAS, so the E stands for this. We got to take care of that first. 6 times 2 will come after it. 2 squared, well, that's 4. PEM, multiply, that comes next. 6 times 2 is 12, plus 4. And then on the other side we have 16, and we know 12 plus 4 is 16, which does in fact equal 16. So this way we've known that we have gotten the correct answer. This is the answer. That's what should be circled. This is just the proof that we have to assure ourselves we found the right value. So let's go ahead and look on your worksheet, page 265, I believe. Yes, I remember this time. Let's get this stuff out of the way. And let's look at this first section. And let's do A and B together. And then I'm going to ask you to pause to do the others, and I'll go over the answers. So A, we have 3x plus 2 equals, what is it? 11. And then B, we have x over 4 minus 3 equals 1. All right, making sure I copied it correctly. There we go. All right, the first job is to get rid of the older kid. Hopefully you remember that means we're subtracting, but we've got to keep it the same on both sides so that this is gone. We still have the baby at home, and now we've got a 9 on this side. This should start moving a little quicker for you, just like I'm going more quickly now. All right, we undo that by dividing by 3. Again, we keep it equal on both sides. So this disappears, baby's left home. 9 divided by 3. You should have 3 as your value for x. Then we check it. Instead of 3 times x, 3 times 3 plus 2 equals 11. Well, 3 times 3 is 9. 9 plus 2 is 11, and that certainly equals 11, so it did check out. Last one we're doing together. What do we get rid of first? The older child, of course. The firstborn. How do I undo subtraction? By adding it back. Now it's gone, but I've kept it equal on both sides by adding it to both sides. I still have baby at home, x over 4 equals, now on this side I have 4. Do not make the common mistake of just writing x equals 1. Watch out, show your work, because this is already dividing. To undo it, you should remember that we're now multiplying. So that this is gone, I've undone that division problem. So Mama's home alone, but on this side it's 4 times 4. We had to multiply to undo the division. We get x equals 16, so let's check it out. Instead of x divided by 4, 16 divided by 4, remember that's a fraction bar, it means division, minus 3 equals 1. 16 divided by 4 is 4. 4 minus 3 is 1, and that equals 1. So we've solved it accurately. Go ahead and pause, do C through H. There are a couple of you that are also leaving out the green letters. Remember I said we're doing green unless I tell you otherwise because we're not doing homework. Go ahead and do those, work them out in the space provided, and then unpause. Let's check the answers. For C, you should have x equals 6. You had to add 9 to both sides first, and then you had to divide by 5 as your second step, so x equals 6. D, x equals 6. They like 6s today. We had to subtract 3 from both sides, and then we had to multiply by 2 on both sides as our second step. And I hope you showed your checking, because I'll look for that when you send me those pictures. E, x equals 1. In this case, we had to solve the 5 plus 2, just like we were doing last week. So once we've gotten that side taken care of, you have 7x equals 7. Very easy peasy to divide by 7 on both sides. All right, F, very similar. We're now simplifying the side apart from the variable. So we have x plus 8 equals 9. It's not 3 times 2. It's 3 multiplied twice. So 3 times 3, 9. And you have x plus 8 equals 9. Now you can subtract the 8 from both sides. G was very similar to this one. It just gave you a division part first and then an exponent. So your first thing was to take care of that exponent. 2 squared is 4. Then you can subtract the 4 from both sides. And the last thing you do is multiply by 3 on both sides. You should have x equals 3. So if you have those incorrect, go back and check your steps, write your work. And then H, you should have x equals 8. Simplify that 3 squared, we have 9. Then you had to add 7 on both sides to keep it equal, keep it balanced. And then you had to divide by 2 as your last step. Okay. So that's how we do 2-step equations. You even did a 3-step for G, just like this one, where we had to take care of some exponents as well as do the 2 main steps. All right, section 2, I want you to go back and find these answers. You've got 2 multiplications with compound measures, an addition and a subtraction with compound measures. So work those out, pause. And then now that you are ready, unpause. Or unpause and now listen. We're going to go over the answers. So for number 2A, you should have 18 pounds, 24 ounces, which we can change to that 24 ounces, another pound, 8 ounces. So your final answer should be 19 pounds, 8 ounces. B, when you add them all up, you get 14 weeks and 13 days. That is definitely a week right in there. So we have to add in a week and we have 6 days left over. For 15 weeks, 6 days is your total answer. C, when you multiply, you have 42 gallons, 21 quarts. Well, that 21 quarts is 5 gallons already, plus a quart left over. So our total is actually 47 gallons and 1 quart. And then D, when you subtract, we had to borrow from the 9. We had to borrow 12 inches and put it with the 3 to help it out. So it becomes 8 feet 15 inches minus 2 feet 7 inches. So we're left with 6 feet 8 inches. Okay. Normally we don't do the back sides of these ones all the time. Either we're crunched for time or we've got other things going on. But we are going to do this side today because it's a strategy and a skill that is useful for many types of percent problems, word problems, geometry problems. We use proportions so many times throughout all different scenarios in math. So we're going to go over using proportions. And if you jump all the words, because that can just be a bunch of gobbledygook, and you're like, I don't know what they're saying. All right, listen, when they're talking about solving with proportions, go to where the blue letters say solve in all caps. We've got 5/7 equals 8/10. They're showing us this. Here's how proportions work. When you have two equivalent fractions or two equivalent ratios, sometimes we call them that, depending on how they're being used, but it's the same thing. You need to know that cross products, here I'm going to use colors, are the same. Okay? If I know that these are equal, these should be, someone dried out my marker, that is not cool. These should be the same. So if I multiply these two, and I get 56, and I multiply these two, and I get 50, there's no way that these are equal, okay? They're simply not. It's not going to work, okay? So the way that we solve to find out what makes them really equal, because cross products would have to be equal, sometimes they'll put a variable in the place, and then we're going to find out what would make it equal. It's not going to be 8/10. We know that we can solve these two. I'm going to switch colors again. I like using colors. So when you're doing proportions, you're going to multiply for what we call a cross product. That's your first step. 7 times 8 is 56. Now, when I used the scenario 8/10, I did not get the same product. So we need to find what would give us the same product. So our second step is to divide by the number that's left. It's left. Okay, so we have 56. And we're going to divide it by 5. We got 56 by multiplying to find the cross product. 7 times 8. We always go from the bottom up to the top, and that will come in another skill later, why that's important and why it will help you out. Just do it my way, because I'm a control freak, and I said 7 times 8 is 56. We're going to divide that by what's left. We know how to divide, super easy. 1. Decimal point. We don't do remainders here. 5 goes into 10 twice. So that is what x is. 11.2 is the value of x. That's what would make it equal. So 5/7 is the same as 8/11.2. That's what's going to solve it. Okay. So using this method, let's find the missing numbers in our proportions down here. Okay. If you look at A, we have 3/7 equals, what do I have? X/11. So this time, the missing number is on the top. Well, I can't find the cross product here. That's not going to work. Where can I find the cross product? Right there, 33. Okay. What's left? 7 is the one that's left. I haven't done anything with it. That's how I know I'm not dividing by 11. I'm not dividing by 3. So the marks aren't just there for color purposes or to make things more cheerful. It's to remind ourselves and draw our eyes' attention to the fact that this is the one that's left over. So even when I was doing college courses, in regular pencil, didn't have to be pretty colors, but I would circle and then I could see what was left over. Just like when we do order of operations, I underline the part that I'm doing before I do the next step. It's just good to help draw our eyes' attention to where we need it to be. All right. 33 divided by 7, 4 times, 5 left over, 7 times, I think we're going to end up with a interesting situation here. And sometimes it'll say round to the nearest tenth. I'm making sure I've got the right problem. Yes, I do. All right. So sometimes they'll say round to the nearest tenth if it's a problem that's going to keep going. Okay. Or you could make it an improper fraction and divide that way. So this is going to keep going. I'm using this to help me round. I'll put it down here. X equals about 4.7. So we multiplied, then we divided, and we get 3/7 is the same as 4.7 over 11. Let's do one more with B, and then I'm going to have you guys do the remaining 2 on the page. Here's where we have x over 7 equals 5 over 13. Making sure I'm copying this right. X over 7 equals 5 over 13. All right, again, I can't find the cross products this way. This time it's back to these two. 7 times 5 is 35. What's left? My 13. So let's instead of doing a box, let's say you prefer to do it as a fraction. Okay, we're still taking our cross product and dividing by what's left, but if you wanted to do it this way, that wouldn't be a problem either. So we've got, would go in twice, would get us 26, and we would have 9/13. Here would be our value. It's just weird doing it this way because you would have a fraction in the fraction, but it's still the correct value. So if you prefer to do it the decimal way, good. If you prefer to do it the mixed number and fraction way, no problem. But usually we round to the nearest tenth when we're finding the decimal one. Go ahead and do C and D, and then unpause when you are ready to go over the answers. All right, C, you've got 2 over 9 equals 7 over x. What can you multiply? Your 9 times 7, which gets you 63. What was left was 2. When you divide it in half, we get 31.5. D, this is one where it's probably easier to do it as a mixed number rather than in the decimal version. When we multiply, we get 20 times 5, which is 100. And we divide that by 7. When you divide by 7, your mixed number would be 14 2/7. If you did it the decimal version, we know that this would go in, trying to do this quickly but correctly, 14. Annex the 0, and remember we want to go 2 decimal places so we know how to round it properly. All right, so this is going to be 2. 7, 8, there we go, because that's going to be 56, and we can stop, but this lets us know that our value would be 14.3 if we were using the decimal version for problem D. If you went with the fraction version, it was 14 2/7, but 14.3 would be the decimal version it would round to. Right? So it's a very simple method, but it's just learning how to utilize what we call proportions when you have two equal fractions and one of the values are missing and it doesn't go in perfectly evenly. 2 and 9/13, 4.7, 14.3, and so on. Okay, so that should be everything for those pages. Really, you have all the answers thanks to this video lesson, but it's up to you to make sure you have all the work and have shown all your steps properly if you're going to get credit for this sheet today. All right, we'll see you next time, and hopefully you're joining our English lesson today. We'll see you later, and hopefully I'll talk to you live in our Zoom session. Bye.